All right, this is a video that's going to tie up some loose ends from sections 4.1 to 4.4 so that we can start reviewing, doing a couple practice AP free response questions, and then test on unit 4.1 to 4.4. So the first topic we're going to cover today is distance versus displacement. All right, so let's start off with some background vocabulary. All right, we're going to say that distance is the distance from the starting point to the ending point. Like, so for example, say I have a particle that starts at position 0, all right? The particle travels to position 5. Then the particle travels back to position 3. So my ending position is position 3. Now, displacement is the distance from the starting point to the ending point. So for this scenario I just gave you, the displacement would be 3. It's the distance from the starting point to the ending point. First we went we went in the positive direction 5 units, and then we went backwards 2 units. All right. So first we had a positive velocity followed by a negative velocity, but our displacement ends up giving us 3. So on an interval AB, you find displacement by integrating the velocity. So this idea right here, you have to make sure that you remember that displacement is the integral from A to B of the velocity. Now, distance is a little different. The total distance a particle travels. So let's look over at this situation or the example that we just went through today, or up top. First, our distance was, first we went 5 units, and then we went 2 more units. So for this scenario that I just gave you, our distance was 7, because I traveled 5 units and then 2 more units. So for distance, you have to consider how the total amount that you actually traveled. And in order to take care of this positive distance plus the negative distance, we're going to have to use an absolute value. So for distance, total distance a particle travels, on an interval AB, you find distance by integrating the absolute value of the velocity. So like if I took the absolute value of each of these, if it was a velocity graph, if I took the absolute value, we would get the distance, because we have to consider the distance a particle travels when it's also moving in the negative direction. So whenever I ask for distance, you should think about integrating the absolute value of velocity. So put a box around this, whatever you have to do to remember. So displacement, integrate velocity; distance, integrate the absolute value of velocity. All right, so let's start off with an example that has to do with this. Consider a particle moving along the x-axis, where x of t is the position of the particle at time t in terms of distance from the origin, and x of t equals t cubed minus 6t squared plus 9t minus 2 for t being between 0 and 5. All right, so we're given a position function. I know that if I want to actually work with a distance, which we're going to have to in a second, I'm going to need the velocity function. So find the total displacement of the particle during these 5 units of time. All right, so first let's make a decision. I got to use the displacement function. That's the integral from, this time it's 0 to 5. Well, actually, we can write out the generic one first, just to review. The integral from A to B of v of t dt. Now, for this problem, I'm given x of t, which is position, and that was t cubed minus 6t squared plus 9t minus 2. Well, I need the velocity to find the displacement. So my velocity is, remember, we just take the first derivative. So that's going to be 3t squared plus 12t plus 9. And now we'll just integrate this velocity function from 0 to 5. All right. So actually, it looks like I made a mistake here. Let's look back up here. I took the derivative of x of t. This should be a negative 12t right here. So let's fix that, make that minus 12t. Then this should be minus 12t. Now, something that we're going to be working on, we could apply the fundamental theorem of calculus here and evaluate, but I actually want to save some time. So this time, you guys can kind of start. You'll still have to use the long way, but we'll check our work with the calculator here and solve it with the calculator. So I'm going to integrate with the calculator this time. Let's go to calculate. All right, after calculate, I press menu. After menu, I go down to calculus. And then I can choose integral. All right, and my integral shows up. I'll enter my bounds 0 and 5. Then I can just enter my function 3t squared minus 12t plus 9, and then let's put our dt here. All right, and then when we integrate, we end up getting 20. So if I would have applied the fundamental theorem of calculus here, I would have got 20. So my displacement is 20. Or 20 units if you wanted to say, because we're going to have to talk about units today. 20 units. All right. Now, let's move on to finding the total distance. So now for distance, we're going to need the absolute value of the velocity. And we're going to integrate on the interval AB. So we're talking about the interval from 0 to 5, because the first 5 units of time. My velocity from before was 3t squared minus 12t plus 9, and then dt. Now what we could do is, like I taught you in class, we could break this absolute value up into a piecewise function and then integrate 3 times, but I don't really want to do that. I'm going to save us some time. So let's go to our calculator actually. All right, so for our calculator, we go to calculate, menu, option 4, calculus, option 3, integral. I'm integrating from 0 to 5. Now, what I'll do from here is the absolute value symbols for the calculator. Go to this delete button, and then diagonal from the delete button, we have a bunch of other options. All right, so it's like right next to the 9 is where you get absolute value. So I'm going to type in, I'm just going to select this option that's absolute value, and we'll type in 3t squared minus 12t plus 9, and then we'll add our dt. And I end up getting 28. So the particle travels a total of 28 units. That's our total distance. So the big thing that you got to get here is for distance, you integrate the absolute value of velocity. For displacement, you integrate just the velocity. All right, go ahead and pause the video. You can try this, you try. The main thing I'm looking for is set up each integral, and then on Monday in class you can integrate with the calculator for each you try. All right, so just show me how you set up the integral first. So go ahead and pause the video, try the you try. All right, then I'm going to keep going. All right, So we have if the particle moves along the x-axis, the position of the particle is given by x of t equals t minus 1 times the quantity t minus 3 squared. Find the total distance the particle travels. All right, so we're talking about total distance. Let's first write what we need. A to B of the absolute value of v of t dt. So be careful, look at what I asked for. All right, so I have the position. That means I need to find the velocity. We can use the product rule. So I'm going to have, because there's a multiplication sign here. So the derivative of t minus 1 is 1 times t minus 3 squared plus t minus 1 times, we got to use the chain rule, so I'm going to have 2 times t minus 3, subtract 1, and then multiply by the derivative of the inside, so times 1. All right, so then that gives us t minus 3 squared plus 2 times t plus 1 times t minus 1 times t minus 3. All right, now we can factor, so let's factor out a t minus 3. And I'll be left with t minus 3 plus 2 times the quantity t minus 1. Keep going, so I have t minus 3 times t plus 2t is 3t. All right, minus 3 minus 2 would be minus 5. All right, so I'm integrating from, actually I should have said over here in the question on 1 to 6. All right, so now let's set up our integral from 1 to 6 of the absolute value of t minus 3, 3t minus 5 dt. All right, and then I'll just go ahead and you can even multiply that together. You can make it 3t squared minus 14t plus 15 if you want to. But I'll just put this in the calculator in factored form. It'll do the same thing. So menu, option 4, option 3. All right, we're integrating from 1 to 6. Absolute value is right next to the 9. All right, so I'm going to have parentheses t minus 3, parentheses 3t minus 5 dt. And we get 47.3704. Just write all the decimal places, 47.3704. All right, that's our total distance that we traveled. All right, so go ahead, in your notes, just write down what questions you have, and I'll make sure that I get them on Monday. All right, now we're going to do the same thing kind of graphically now, so you get a graphical representation of velocity, distance, and displacement. This is going to include some review of our derivatives unit from back in November and December. All right, the velocity of a moving object v of t measured in feet per second is represented by the graph to the right on -4, 3. All right, so we're on -4, 3. When is the object at rest? So this is not an integration question. This is a question from previous units. An object is at rest when the object isn't moving or the velocity equals 0. All right, so now let's just look at the graph. All right, it's a velocity graph. I have to see this when the velocity equals 0. I see that's at -1 and 1. All right, so That's the first one, just objects at rest at these two times. All right, that's when the velocity equals 0. All right, evaluate the integral from -4 to 3 of v of t dt. Explain the meaning of the result. All right, well, one, I'm integrating just the velocity, so this is the displacement. All right, that's based on what we learned on the last page. All right, so that is just the displacement because we're not integrating the absolute value. Explain the meaning of the result. All right, so let's go ahead and do that. I have to integrate from -4 to 3. So I'm going to use geometric formulas here. Just break it up. All right, this is a trapezoid. The bases are 1 and 3. The height is 2. 1 plus 3 is 4. Times 2 is 8. Divided by 2, I get 4. It's a triangle with base 3, or base 1, height 3. So I divide that by 2, I get 1.5. Here's a triangle with base 2, height 1. So right, but then it's negative, so the area of this is -1, because 2 times 1 divided by 2. And right here, I have 2 times 1 divided by 2. That's going to be -1. So when I add these up, I have 4 plus 1.5 minus 1 minus 1. That's 5.5 minus 2, or 3.5. So that's our displacement. Find the total distance traveled over the interval from -4 to 3. All right, the total distance is the absolute value of the velocity integrated over that time period. So let's just look back over here. The absolute value of this function, I would flip these bottom parts of the graph up. They would become positive. So really what I'll do when I find the total distance, just add up all of the positive versions, or the positive values that you see for the areas. So we're going to have 4 plus 1.5 plus 1 plus 1. Because the absolute value of -1 is 1, the absolute value of -1 is 1. So we're going to have 4 plus 1.5 plus 1 plus 1, which is 7.5. All right, just add up all of the positives. All right, at t equals -3, is the particle speeding up or slowing down, and why? All right, so we got to go to -3. All right, but before we do that, let's review. Speeding up means the velocity and acceleration have same sign. Slowing down means v of t and a of t have different signs. So let's start off with that t equals -3. All right, let's go to -3. All right, that's right here. So 1, 2, 3. T equals -3 is this point right here. So at this point right here, I can see my velocity is positive because I'm above the x-axis. To find the acceleration, I have to find the derivative of velocity. That's slope, the slope of the graph. So a of t is also positive at this point. All right, so I would say speeding up. All right, v of t and a of t have the same sign. I should actually write this out. Now, t equals -1. Let's check that one. All right, actually, I should write out my justification. All right, let's go to -1. All right. Actually, yeah, -1. That doesn't make sense because we already said that the velocity at -1 was 0. So let's go ahead and let's make this t equals 2. We'll just do t equals 2. Sorry, should have said t equals 2. All right, so at t equals 2. All right, looking at t equals 2, that's right down here. All right, here, the velocity is negative. I'm below the axis. Also, the slope of my graph is negative, so my acceleration is negative, which would mean that our particle is also speeding up. All right. And then if I found a spot like where the velocity and acceleration are different, like let's look at like -1.5 right here. Like at this point, my acceleration is negative, but my velocity is positive because the point is above the x-axis or above the t-axis. So like right here, we would be slowing down. All right, so that's a review of velocity, displacement, and distance. All right, next part, kind of tying up some loose ends. Now, I know that a lot of you guys had questions on Riemann sums from tables, so I'm going to show you some shortcuts right now. So a review of Riemann sums from tables. All right. Use the table of values to estimate the integral from 0 to 6 of f of x dx. Use 3 equal subintervals and left, right, midpoint, and trapezoidal sums. All right. So let's go ahead and do that on the next page. All right. So for part A, I said use left endpoints. And I want 3 subintervals. All right. So if there's 3 subintervals, my delta x is 6 minus 0 over 3, which is 2. So let's just go to my table, and every subinterval should have a length of 2. All right. So those are all my widths. These are my delta x's. Now for the heights, I just take the values of the left endpoint on that interval. So I'm going to do 2 times -6 plus on the next interval 2 times the left endpoint on this interval is 8. And then the last one 2 times 30. All right. And then we can just make that -12 plus 16 plus 60. That's 4 plus 60 or 64. All right, that would be our area. Now let's do the right endpoints. All right, we're still talking about 3 subintervals. So now for the right endpoints, all my widths are still 2. So I just take 2 times the value on the y value on the right for each subinterval. So I'm going to have 2 times 8 plus 2 times 30 plus 2 times 80. That's 16 plus 60 plus 160. That's 76 plus 160 or 236. All right. So you just take the width times the y value on the right. Now, for part C, for midpoints, we still have 3 subintervals. All right, you just take each delta x and multiply it by the y value of the midpoint in the interval. So I'm going to have 2 times 0. That's our first interval, subinterval. 2 times 18 and 2 times 50. So it's the width times each y value in the middle, or at the midpoint of the interval. So I'm going to have 0 plus 36 plus 100, and I get 136. All right. The last one is the trapezoidal rule. So for the trapezoidal sum, all right, my delta x is my height. That's the height of the trapezoid. And then base 1 and base 2 are the y values at the ends of the subinterval. All right, so let's go ahead and do the first subinterval. So I'm going to have 1/2. All right, base 1 and base 2 are -6 and 8 times the height, which is 2, plus 1/2 times. On the next subinterval, my bases are 8 and 30. Times the height, which is 2. Plus the last one, 1/2 times 30 plus 80 times my height, which is 2. All right, on each of these, I can kind of notice a pattern. The 1/2 and the 2 is going to cancel, so I'm going to have -6 plus 8 plus 8 plus 30 plus 30 plus 80. All right, so that's 38 plus 110 plus 2. So that gives us 150. All right. What I'm going to have you do now is go ahead and pause the video. You'll need a calculator for this question. Yeah, you can set it up with a calculator and then check your work. So the table below lists measurements for a lot bounded by a stream and 2 straight roads that meet at a right angle. You're going to do right endpoints, left endpoints, and midpoints. For the right and left endpoints, n is 6. For the left endpoint, n is 3. And then there's a different question on trapezoids on the next page. So go ahead and do this one first, and then we'll check. I'm going to get started. You can pause the video. All right. So it says 6 subintervals. So let's just do our delta x first. That's going to be 300 minus 0 over 6. So each subinterval is 50. So let's go up to the table. And I can see my table is already going by 50s. Cool. All right. On each subinterval, just take the value on the right. So I'm going to have 50 times 362 plus 50 times 305 plus 50 times 268 plus 50 times 245 plus 50 times 156 plus 50 times 0. All right. You can factor out a 50 if you want before you put it in the calculator. So 50 times 362 plus 305 plus 268 plus 245 plus 156 plus 0. And I'll just put that in a calculator. All right, so I'm going to have 50, all right, times parentheses 362 plus 305 plus 268 plus 245 plus 156 plus 0. And we'll get 66,800. All right. Next, on our left endpoints, we'll do the same thing, just take all the y values on the left side. All right. So now I'm going to have 50 times 450 plus 50 times 362 plus 50 times 305 plus 50 times 268 plus 50 times 245 plus 50 times 156. All right, we're using the left endpoints. You could factor out a 50, or you could have done that at the beginning too. Let's just type it in. So I'm going to have 50 times parentheses 450 plus 362 plus 305 plus 268 plus 245 plus 156 right here. And I get 89,300. All right. Now, last one for this problem is midpoints, but it says n equals 3. So we got to find our new delta x. That's going to be 300. The last x minus the first x. So each subinterval should have a length of 100. So I'm going to go up here. Let's just go ahead and we got to write new delta x's. So I'm going to have 100, 100, and 100. I go from 0 to 100, 100 to 200, 200 to 300. All right. Now let's go ahead and just take each delta x times the y value at the midpoint. So 100 times 362, 100 times 268, 100 times 156. All right. And then you can factor out a 100. And then do 362 plus 268 plus 156. And I get 78,600. All right. Go ahead and write down any questions that you have so I can answer them on Monday. One more you try. This time it's a trapezoidal sum. Table below gives data points for a continuous function f on 210. All right, we have the x values 2, 5, 7, 8, 10. F of x is 3, 1, 5, 3, 5. All right, using the subdivisions of 2, 5, 5, 8, and 8, 10, what's the trapezoidal approximation of the integral from 2 to 10 of f of x dx? Go ahead and pause the video, and I want you to try this out first. All right, and I'm going to get started. All right, for trapezoidal approximation, they already give us the intervals. So I have 2 to 5, the length is 3. 5 to 8, my delta x is 3. And 8 to 10, my delta x is 2. These are all the heights. All right. All my y values are my bases. So I'm going to have 1/2 times 3 plus 1 times 3 plus 1/2 times 1 plus 5 times 3 plus 1/2 times 3 plus 5 times 2, because the last one has a height of 2. All right. So let's go ahead and simplify. So I'm going to have 1/2 times 4 times 3, that's 6, plus 1/2 times 6 times 3, that's 9, plus 1/2 times 8 times 2. 8 times 2 is 16, divided by 2 is 8. Add those up together. We get 23. 3. All right, so this is a review of Riemann sums, or Riemann sum, left, right, midpoint, or trapezoidal sums from tables. All right, the last part is working with rates. All right, so the first thing that you need to know about working with rates is you need to go nuts when you are working with rates. All right, go nuts. All right, not crazy, just go nuts. So when I say go nuts, I'm talking about a noun, I'm talking about a unit, I'm talking about time, and I'm talking about specific. All right, these are easy ways to get points on the AP test. So you have to go nuts when you're working with rates problems. All right, I need you to remember that. Go nuts. So, first question. If oil leaks out from a tank at a rate of R of t gallons per minute at time t, what does the integral from 0 to 180 of R of t represent? All right, I am integrating a rate, so this should give us an amount. Our rate is in gallons per minute. So if we are going nuts, we have to talk about our noun gallons. When I integrate a rate, that gives us an amount. So integrating this rate of gallons per minute gives us the gallons. All right, that's our noun and our unit. All right. Next, when I integrate this rate, we have to give us our time. It's the gallons of oil, because we're talking about oil. All right, they're leaking, so I have to say that leaked out. Between t equals 0 and t equals 180. Our time is minutes. The first thing that you need to do on all rates problems is look at the noun, the unit, and the time. It's gallons per minute. I might give you items per month, dollars per month, you name it. You have to look at the units first. So minutes. So integrating a rate gives us an amount. All right, I want you to go ahead and do this U try real quick. I need you to go nuts with this U try. All right, if W prime of t is the rate of growth in a dog in pounds per year, what does the integral from 5 to 10 of W prime of t dt represent? Go ahead and pause the video and get started. All right, so I see that my initial rate is pounds per year. I'm integrating a rate, so when I integrate this rate, I just get pounds. All right, so this would be pounds that the dog gained from t equals 5 to t equals 10 years. All right, so it's just our total pounds that they gain between 5 and 10 years. All right. Now, last example for the video. The rate at which ice melts is given by dv dt equals the square root of 4 plus e to the t power, where v is the volume of ice in cubic feet and t is the time in minutes. How much ice has melted in the first 4 minutes? All right, so let's go ahead and I need to integrate this rate to get the amount because I'm asking how much. All right, so I need to integrate the rate to find out how much. So the integral from the first 4 minutes will be from 0 to 4 of the square root of 4 plus et. Remember your dt. Now, this seems like a really hard function to integrate. I can't really apply any rules that you guys have learned so far. So this is probably a good calculator question. All right, we can knock this out with a calculator. So let's go to option 4. Actually, not that. Menu option 4, option 3. We're integrating from 0 to 4 of the square root of 4 plus e to the t power dt. All right, now it gave me this long, kind of drawn out answer that's not as a decimal. So what I'm just going to do is just press enter one more time. Still didn't give me what I wanted. So now if I press control followed by enter, it changes it to a decimal. So I press the control button followed by enter, get 15.524. For 15.5424. All right. Last you try. All right. This doesn't require a calculator, so you can do this without a calculator. A faucet was turned on at t equals 0, and t minutes later, the water was flowing into the barrel at a rate of t squared plus 4t gallons per minute. How much water is added to the barrel during the first 4 minutes? Find the average flow rate for these 4 minutes. Go ahead and pause the video and try this problem. All right, I'm going to get started. Set up the integral from 0 to 4 of t squared plus 4t dt. All right. Let's integrate. The integral of t squared is t cubed over 3 plus 2t squared. So it's going to be 4t squared over 2. From 0 to 4. Plug in 4 and 0. So we're going to have 64 over 3 plus 32 minus 0 over 3 plus 0. 64 over 3 plus 32. Common denominator is 3, so we have 64 over 3 plus 96 over 3, which is 160 over 3. Now, there's something that's problematic about my answer right now, and there's something that's problematic about my last answer. I hope that you caught it and you were thinking, but I'm trying to have you do a little bit of error analysis. I need you to look back at my example 5. The problem is that I did not go nuts here. I did not include my, I did the problem, I did the calculus, but when you do calculus, you have to go nuts. So, it says how much ice has melted. All right. It says our volume is in cubic feet. So this answer would be in cubic feet. All right. So let's correct that. Now, what's problematic about the answer here? My rate was in gallons per minute. So my answer should be in gallons. All right. Got to go nuts. Now, find the average flow rate for these 4 minutes. So average rate is going to be 1 over b minus a times the integral from a to b. It's like average velocity. Velocity is a rate. So when I do average rate, I'll use the same formula. 1 over b minus a times the integral of f of x dx. So I'm going to have 1 over, for this problem, 4 minus 0 times the integral from 0 to 4 of t squared plus 4t dt. That's 1 over 4. I already solved this part in the last problem, times 160 over 3. All right, that's 160 over 12. And you can reduce the fraction if you want. You can make it 80 over 6, which is 40 over 3. Now, let's analyze our units. So the units on 160 over 3 were gallons. The units on 4 are the time for the problem because 4 and 0 were time. So these were minutes, and that's in the denominator. So really I have gallons and then minutes in the denominator because the time is in the denominator. And we're talking about the average flow rate. So our answer should be in gallons per minute. All right. This concludes the video, wrapping up some of the ideas from chapter 4.1 to 4.4. Thanks. Go nuts.